All right, let's talk about that first-year chemistry exam, BSCH 202. I know, it's coming up fast, and if you're staring at that syllabus feeling completely overwhelmed, you are definitely not alone. But what if I told you the secret to acing this thing isn't about studying harder, it's about studying smarter? In this explainer, we're going to crack the code of the exam itself and build your ultimate survival guide. So let's just dive right in.
You look at a past paper like this, and it can be pretty intimidating, right? The syllabus feels enormous, there's so much to cover, it's just really easy to feel lost. But here's the thing. What if the biggest clues to what's important were hiding in plain sight this whole time? We're about to put together a study plan that focuses your energy exactly where it's most likely to pay off on exam day.
So here's our game plan. First, we're going to crack the code. Then, we'll take that code and apply it to the three biggest pillars of this course: the crazy quantum world, the rules of energy and equilibrium, and finally, the logic of molecules. And to wrap it all up, we'll build a powerful strategic study plan you can start using literally today.
So, what is this big secret? Well, honestly, it's not a secret at all. The key to this entire exam is hidden in the one place everyone has but almost no one really uses to its full potential: the end-of-chapter questions in your own textbook.
No, seriously, think about it for a second. What if the very questions that your professors gave you to test your understanding are actually the best possible preview of your final exam? That's our whole premise here. The exam writers are basically giving you hints, and we're about to learn exactly how to read them.
Okay, first up, the quantum world. This is where we get into all the fundamental rules that govern atoms and electrons. I know, it can feel super abstract, but your textbook tells us precisely where to focus our attention.
And here it is, our first piece of solid evidence. Just look at these questions, pulled straight from a textbook chapter. Do you see the pattern? They ask about quantum numbers, and then they ask about them again. De Broglie's equation and Heisenberg's principle also keep popping up. You know, this isn't a coincidence. It's a giant neon sign pointing right at what you need to master.
So, becoming fluent in quantum mechanics starts right here with these things called quantum numbers. Just think of them as the unique address for every single electron in an atom. They tell you its energy level, that's N, the shape of its orbital, L, its orientation in space, M, and its spin, S. Honestly, if you can clearly explain those four numbers, you are already halfway there.
So, here it is, your quantum mechanics checklist. You absolutely have to know de Broglie's idea that particles can act like waves. You need Heisenberg's uncertainty principle down cold. You've got to be able to build electron configurations using the rules. And of course, be ready to sketch out the shapes of those s, p, and d orbitals. That's the core of it.
But, and this is a big but, knowing the theory isn't enough, and this slide right here proves it. Your textbook is packed with numerical problems just like these. See, they aren't just asking you to define a concept, they're testing if you can actually apply the math. Can you calculate the wavelength of an electron or the uncertainty in its position? That's the real test. And to do that, you're going to need your tools. The number one most important tool in this section is the de Broglie equation. Lambda equals Planck's constant divided by mass times velocity. This beautifully simple formula connects the wave property, lambda, to the particle property, momentum. Trust me, you will use this a lot. All right, let's shift gears to our second pillar, thermodynamics and equilibrium. This whole section is about the why and the how of chemical reactions. You know, why do some reactions just happen, while others need a serious push to get going? And guess what? Look at the clues in the textbook once again. Question after question hammers on the laws of thermodynamics, on Hess's law, and on that absolutely critical concept of spontaneity. They want you to be able to look at a reaction and predict if it's going to go. And the key to predicting that is this thing called Gibbs free energy, or delta G. The best way to think of it is like a ball on a hill. If delta G is negative, the ball is going to roll downhill all by itself. The reaction is spontaneous. If delta G is positive, you have to push that ball uphill. The reaction won't happen without energy. And if delta G is 0, the ball is just sitting on level ground. It's at equilibrium. That's it. The sign of delta G tells you everything you need to know. So your study guide for this entire section really just boils down to these four ideas. First, you need the fundamental laws of thermodynamics. Second, you got to know how to use Gibbs free energy to figure out if a reaction is spontaneous. Third, you need to connect that energy to batteries and electrochemistry. That's where the Nernst equation comes in. And finally, you use Le Chatelier's principle to predict how a system in equilibrium is going to react when you start messing with it.
Okay, our final pillar takes us into the amazing world of organic chemistry. Here, everything is about the three-dimensional structure of molecules and how that structure completely dictates how they react. It's really like the architecture of life itself.
So what does the textbook practically scream from the pages? Mechanisms. I mean, just look at question 8 here. It's so direct. Which of the reactions follows SN1 and which one the SN2 mechanism? They are making it crystal clear that you need to understand the step-by-step pathway of these really fundamental reactions.
Knowing the difference between these two is absolutely essential. So think of it this way. SN1 is the tortoise. It's a slower, two-step process that forms a stable little intermediate along the way. Its speed only depends on one thing. SN2, on the other hand, is the hare. It's a super fast, one-step attack. Its speed depends on both the molecule being attacked and the attacker. Tortoise versus hare, 2 steps versus 1. That is the core difference you have to know.
But it's not just about how molecules react. It's also about their 3D shape. Look at this. Question 9 asks you to tell the difference between enantiomers, diastereomers, and mesocompounds. This is all about stereoisomerism, how atoms are actually arranged in space.
So, what even are stereoisomers? The easiest way to think about them is to just look at your own hands, right? They're mirror images of each other, but you can't perfectly stack one on top of the other. That is exactly what stereoisomers are. They're molecules with the same formula, same connections, but they're non-superimposable mirror images. Now, this might sound subtle, but it's hugely important in fields like medicine, where the left-handed version of a drug might save your life, while the right-handed version could be totally useless or even harmful.
Okay, we've gone through the evidence from the textbook, we've identified the topics that give you the biggest bang for your buck. Now, let's put it all together into a simple, powerful, and totally strategic study plan. Here it is, just 4 steps. Step 1, focus your precious time on our 3 pillars. Step 2, for each of those pillars, you have to master the core definitions. Quantum numbers, Gibbs free energy, stereoisomers, you know the drill. Step 3, and this is without a doubt the most important one, actually do the end-of-chapter problems for those topics. And finally, step 4, don't just memorize. Try explaining these concepts out loud, to a friend, to your pet, to the wall. It doesn't matter. If you can teach it, you know it. So, let this be your mantra for the next few weeks. The path to doing well on this exam isn't some hidden mystery. It's right there in the textbook problems you've been assigned all semester. They are your single best resource. Use them.
See, you're not just studying anymore. You're studying with a real strategy. You have the map to this exam, and it highlights exactly where all the treasure is buried. So the only question left is, are you ready to go get it? Good luck.